Good morning. I am Ashagila Devi, Assistant Professor in Department of Computer Science and Engineering in Rohini College of Engineering and Technology. So, in today's session, we are going to explore one of the most evolutionary concept of modern AI, that is Generative Adversarial Network, that is GAN. Okay. First, we are going to see the introduction about the GAN. Okay, so GAN were introduced in the 2014 by Ian Goodfellow and his team. They completely changed the field of AI by enabling machines to generate realistic images, such as images, audios, and even videos. That is, generate realistic data. So GAN follows an unsupervised learning approach where the goal is to generate a new samples that look very similar to the original data. So the uniqueness of GAN lies in its structure. They consist of two neural networks to generate and for discriminator. So which compete with each other. This competition helps the model to improve continuously. And the components of GAN, there are major of two main components. First one is the generator, second one is discriminator. So generator creates fake data that mimics the real data set. So it learns the patterns from the training data and tries to produce a sample that appeals real. And discriminator act like a judge. It distinguishes between the real data and the fake data produced by the generator. So generator tries to fool the discriminator and the discriminator tries to correctly classify. So this adversarial relationship is the reason behind the name of generative adversarial network. Next, example of fake versus real currency. To understand GAN better, images and real world scenario. Suppose we have a collection of real 100 currency note, and the generator act like a counterfeiter. It tries to create fake notes, and the discriminator act like a police officer. It checks whether the note is real or fake. Over time, the generator becomes better and producing high quality fake notes. The discriminator becomes smarter and detecting fakes. So eventually the generator becomes so good and the discriminator cannot easily differentiate the real and the fake. So this is the point where the GAN is considered well trained. And next is the generator network. The generator starts with the random noise input, usually represents as a vector Z. It transforms this noise into meaningful output using multiple neural layers. So the objective of the generator is simple. It produces data that looks so real that discriminator gets confused. So the generator adjusts its weight based on the feedback it receives from the discriminator through the backpropagation. And the discriminator network, the discriminator is a binary classifier. It receives two types of data: real data from the data set, fake data produced by the generator. So its job is to classify them correctly as real or fake. So the discriminator is trained by using backpropagation to minimize the classification error. As training progress, it becomes increasingly better at identifying fake samples. And next, how GAN works. GAN works through simultaneous training of both networks. The generator produces fake data, that is G of Z, and the discriminator evaluates both, that is D of X, for real data, that is D of G of Z, for fake data. The generator tries to minimize the loss by fooling the discriminator. The discriminator tries to maximize its accuracy by rejecting the fake data. Next is training process of GAN. The training cycle of GAN involves feeding both real and fake samples into the discriminator, computing discriminator loss based on the classification performance, updating the generator by making it try harder to fool the discriminator, and updating both network using backpropagation, and repeating the process until the generator produces the realistic output. Next is example of GAN implementation. We define the generator. The typical GAN implementation involves we define generator and discriminator networks, use binary entropy loss functions, use optimizer like Adam. It's an alternative training between generator and discriminator. and after each epochs we visualize the generated samples to monitor the progress. As training progress, the generator outputs becomes more realistic. Okay, next is the evaluation of generated images. GAN training improves results gradually. Epoch is equal to 0 means generator produces a pure noise. Epoch is equal to 1000 means simple shapes and pattern appears. Epoch is equal to 10,000 means output is realistic. For example, digits similar to the MNIST dataset. Okay, so at this point, the discriminator finds it increasingly difficult to distinguish between the real and fake data. So this is about GAN architecture. Thank you for listening.